Colorado River is on the edge of another major crisis. Scientists say reservoir levels are falling back to dangerously low conditions.
Under the unyielding glare of a desert sun, the Colorado River has always been more than a body of water. It is the artery that breathes life into the American Southwest. For millions, it sustains agriculture, cities, and ecosystems across 7 states and Mexico. But satellite data released by the United States Geological Survey, USGS, has forced the world to look beneath its shimmering surface. Deep underground, where tectonic forces silently toil, a rift is forming, a rupture so significant that it prompted the USGS to issue a rare red alert, a designation reserved for imminent geological threats. What the satellites captured was not just a crack in the Earth's crust, but a sign of something larger, more ancient, and far more dangerous stirring beneath one of America's most vital waterways. Before we start, hit the like and subscribe buttons for more exclusive news. The first hints of the anomaly appeared weeks before the official announcement. A cluster of satellites, orbiting hundreds of miles above the Earth, began registering subtle shifts in ground elevation along a 60-mile stretch near the river's lower basin. At first, scientists assumed it was routine subsidence, the slow settling of land caused by groundwater depletion or drought. But the pattern didn't fit. The shifts weren't gradual, they were directional, converging toward a single elongated fissure that appeared to be expanding over time. When radar interferometry confirmed lateral displacement, a telltale sign of crustal separation, the implications became undeniable. A rift was opening, deep and potentially spreading. By the time the USGS convened its emergency press briefing, internal reports had already circulated among geophysicists, hydrologists, and emergency planners. The red alert wasn't just a bureaucratic formality, it was a warning that the stability of an entire watershed might be in jeopardy. Beneath the arid plateaus and sandstone canyons, tectonic plates are constantly shifting, but rarely has such activity occurred beneath an active river basin with this degree of intensity. The Colorado Plateau, often considered geologically stable compared to the volatile Pacific margin, now revealed a hidden dynamism that defied assumptions. The imagery released by the satellites was haunting. In false color composite, the rift appeared as a dark scar running parallel to the river's course, widening toward the southeast. In some sections, analysts estimated the fissure had already opened to nearly 15 feet across and extended several miles below the surface. Infrared sensors detected thermal anomalies, suggesting the presence of geothermal activity or deep frictional heat from crustal movement. The combination of vertical displacement, heat signatures, and hydrological disruption painted a picture of a subterranean system under strain. Geologists studying the phenomenon noted that the rift's location overlapped with known fault lines that had lain dormant for millennia. The most concerning hypothesis proposed that the rift was a reactivation of an ancient tectonic boundary, possibly linked to the basin and range extension zone to the west. If true, it would mean the crust beneath the Colorado River is undergoing active deformation, a slow tearing apart of the continent itself. That possibility unsettled scientists, because such rifts are precursors to new fault systems, or even the embryonic stages of plate divergence. The very ground that supports cities like Las Vegas, Phoenix, and countless communities along the Colorado's course might be shifting in ways that could reshape the region's geography. As word spread through scientific circles, attention turned to the potential causes. Some experts speculated that deep mantle upwelling, a slow but persistent ascent of molten material, might be exerting pressure from below, forcing the crust to crack open. Others suggested that decades of groundwater extraction and the ongoing depletion of the Colorado's aquifers could have weakened the structural integrity of the subsurface layers, creating a fragile crust ready to fail under tectonic stress. Whatever the origin, the synchronization of natural and human factors appeared undeniable. The land had reached its breaking point. Field teams dispatched to the affected region began documenting visible changes on the surface. In several areas near the Grand Canyon's lower reaches, long linear fractures appeared across the desert floor, slicing through rock formations like knife marks. Small collapses and sinkholes were reported near the margins of the river, where water seemed to vanish into the ground. River gauges detected minor fluctuations in flow rate, indicating that part of the river's discharge might be draining into subterranean channels newly opened by the rift. The notion that the Colorado River, already strained by decades of drought and overuse, could be bleeding into the earth sent a chill through every agency that depends on it. The red alert also carried immediate implications for infrastructure. The Colorado River supports one of the most complex water management systems in the world, feeding reservoirs like Lake Mead and Lake Powell, and providing power through massive hydroelectric facilities. A rift beneath its course raises concerns that pipelines, dams, and canals built on seemingly stable ground could face destabilization. Engineers began reviewing structural data, particularly focusing on areas where the bedrock foundation showed signs of subsidence or thermal anomalies. Even a small shift could compromise the delicate balance that keeps these systems operational. Satellite analysts working with the USGS also observed an increase in microseismic activity along the length of the rift. Although the tremors were too small to be felt on the surface, their frequency and pattern suggested that stress was redistributing across the crust. This type of swarm behavior often precedes larger seismic events. The agency's monitoring systems went into round-the-clock operation, cross-referencing data from ground sensors, GPS stations, and aerial surveys. The results confirmed what many had feared. The rift was not static. It was widening incrementally, with measurable displacement occurring every few days. Scientists emphasized that such movement could herald the early stages of a geological transformation, akin to the processes that once opened the Rio Grande Rift millions of years ago. In that ancient episode, tectonic stretching eventually created an entire valley system that reshaped the Southwest. Could the Colorado River now be witnessing a similar rebirth of geologic energy? The parallels were eerie, and while the timeline of such transformations often spans millennia, the pace of the current deformation, accelerated by anthropogenic pressure, suggested a more immediate concern. Environmental scientists were quick to note that the implications extended beyond geology. The Colorado River is the lifeblood of ecosystems spanning from the Rockies to the Gulf of California. Any alteration in its flow could trigger cascading effects, disrupting wetlands, migratory patterns, and the fragile desert biodiversity that depends on consistent water cycles. A newly formed rift could alter the hydrological gradient, changing where and how the river's tributaries converge. In extreme scenarios, portions of the river could be diverted underground, permanently reducing surface flow downstream. Such a scenario would devastate already strained agricultural zones and potentially ignite disputes over water rights across state lines. Researchers from several universities began conducting hydrological modeling to understand how the rift might influence groundwater movement. Preliminary models suggested that water from the river was already seeping into deep fractures, feeding pressurized aquifers below. Over time, these hidden reservoirs could expand, destabilizing the ground above them and potentially triggering more collapses. The interaction between tectonic fractures and water flow creates feedback loops, where stress leads to cracking, which leads to infiltration, which then alters pressure dynamics, perpetuating further instability. It is a process that, once initiated, is difficult to reverse. The red alert also underscored how rapidly Earth observation technology has evolved. Only in recent decades has humanity gained the ability to detect such subsurface shifts in near real time. Synthetic aperture radar, gravimetric sensors, and satellite-based interferometry now provide a level of geological surveillance that was once unimaginable. In this case, those tools likely prevented a slow-moving disaster from going unnoticed until its consequences became irreversible. The satellites revealed not only a physical rupture but a reminder of how connected human civilization is to the forces beneath its feet. Across the American West, scientists began revisiting older fault maps, comparing them with the new data. What emerged was a complex network of potential weaknesses running across the desert basins. Some experts theorized that the Colorado Rift might represent a missing link between existing fault zones, an evolving corridor of deformation that could, in the far future, split portions of the plateau apart. The implications for long-term continental dynamics are immense. The slow fracturing of the crust could signal that North America's interior is entering a new phase of tectonic adjustment. While catastrophic change may not be imminent, the signs are there, a reminder that the Earth's crust is never truly still. As the days following the announcement unfolded, the region buzzed with speculation. Was this rift a localized phenomenon, or the beginning of a much larger shift beneath the Southwest? Geological history offers precedent for both. The region's dramatic canyons, mesas, and escarpments are the visible scars of ancient rifting and uplift events. The crust here has been stretched, twisted, and broken countless times over eons. What makes the current situation extraordinary is its intersection with modern civilization. Never before has such a process unfolded beneath a river so essential to human life. Hydrologists observed with growing concern that the river's sediment profile was changing. Suspended particles indicated possible erosion from new subterranean channels, implying that water was interacting with fresh rock layers. Thermal imaging also revealed anomalies. Warm patches along sections of the riverbed where no geothermal sources were known to exist. This could signify deep convection, where groundwater circulates through newly opened fractures and returns to the surface as warm springs. In isolated areas, local residents even reported faint rumbling noises emanating from the ground at night, a low, resonant sound unlike any known industrial source. Whether these accounts were related remains unverified, but they added a palpable unease to an already tense atmosphere. The USGS response teams deployed temporary field observatories along key segments of the river to gather data on gas emissions, temperature gradients, and soil deformation. Early readings indicated trace amounts of carbon dioxide and methane venting from certain fissures, another clue that geological processes at depth were intensifying. While the levels were not immediately hazardous, their presence suggested that long-sealed pathways in the crust were now reconnecting to the surface. Such vents can evolve over time, expanding into geothermal fields or signaling magmatic intrusion at depth. Although no evidence of magma movement was confirmed, the very possibility drew comparisons to other continental rift zones around the world, such as the East African Rift, where similar patterns preceded major tectonic reorganizations. The scientific community found itself racing to interpret the data. Every new measurement seemed to reveal another layer of complexity. One of the more intriguing discoveries came from gravity anomaly mapping. Small but measurable variations in gravitational pull across the affected area. These anomalies suggested density contrast below the crust, possibly molten or partially molten rock moving upward through weaker zones. If so, it could indicate that the rift's origin lies deeper than previously thought, tied not just to surface strain but to mantle dynamics reshaping the region from below. While scientists grappled with theory, policymakers faced an entirely different challenge. A red alert from the USGS triggers a cascade of interagency coordination, emergency planning, infrastructure assessments, and communication strategies to ensure public safety. Local authorities were advised to restrict new construction near identified fracture zones and to monitor existing facilities for signs of ground movement. Reservoir operators were instructed to watch for shifts in water pressure or unusual seepage patterns. Even transportation departments began evaluating bridge foundations and tunnel alignments in areas where the rift's influence might extend. At the human level, the event stirred both awe and anxiety. The Colorado River has long symbolized endurance, carving its way through rock for millions of years. To imagine it threatened not from drought or human overuse, but by the earth itself, unsettled even seasoned residents of the region. For indigenous communities whose histories and spiritual traditions are intertwined with the rift was more than a geological anomaly. It was a disturbance in the balance of the land. Elders from several tribes spoke of ancient stories describing times when the earth split open and water vanished into the ground, only to re-emerge generations later in new forms. These narratives, once dismissed as myth, now resonated with an uncanny echo of the present. Amid the uncertainty, scientists sought to establish a timeline. Was this rift forming over decades, or had it accelerated within months? Radiometric dating of displaced sediments suggested that minor subsidence had been occurring for years, perhaps unnoticed beneath layers of sand and silt. However, the sharp increase in movement detected by satellites indicated that something had recently changed. Perhaps a tipping point in stress accumulation or an external trigger such as regional seismic activity. Nearby seismographs recorded a cluster of low-frequency tremors weeks before the first satellite alerts, hinting at deep fracturing that only now had reached the surface. The geology of the region offers some clues. The Colorado Plateau is bordered by several dynamic provinces, the Basin and Range to the west, the Rio Grande Rift to the east, and the uplifted Rocky Mountains to the north. These boundaries represent zones of ongoing crustal motion, where extension, compression, and uplift converge in complex ways. Over millions of years, the plateau has acted as a stable block caught between these forces, but stability, in geological terms, is never permanent. The stress accumulating at its edges may now be finding release through the newly discovered rift, a pressure valve venting the strain of continental motion. From a hydrological perspective, the consequences are equally profound. If the rift continues to expand, it could fundamentally alter the river's behavior. Water flowing into deep fractures could change subsurface pressure dynamics, potentially reconfiguring aquifer recharge zones or even reversing groundwater flow directions. Such changes would take years to manifest fully, but the process has already begun. Monitoring wells near the affected zone recorded subtle fluctuations in pressure, suggesting that underground reservoirs are responding to the shifting landscape. For farmers, engineers, and city planners who rely on predictable water patterns, this new uncertainty poses a daunting challenge. Environmental implications ripple outward from the physical changes. The Colorado River Delta, once a lush estuarine ecosystem before decades of damming, could experience further transformation. If the rift alters the river's discharge volume, salinity levels in the lower basin might rise, threatening species adapted to delicate freshwater conditions. Upstream, temperature shifts in water flow could disrupt fish migration and spawning cycles, cascading through the entire food web. Even the region's iconic landscapes, arches, mesas, and sandstone cliffs, might eventually bear the marks of the underlying strain as new faults propagate upward. Beyond the immediate concerns, the event has reignited broader scientific debate about the evolving dynamics of the North American continent. For decades, researchers have speculated that the western interior might one day experience renewed rifting, a continuation of processes that began tens of millions of years ago. The newly observed fissure beneath the Colorado River could represent the first tangible sign of that transformation, a reminder that continental stability is an illusion measured only in human lifespans. While it might take thousands of years for such forces to reshape the land, the evidence now visible from space shows that the process has already begun. Despite the mounting data, there remains a sense of mystery about what exactly lies beneath the rift. Seismic imaging campaigns planned in the coming months aim to construct a three-dimensional model of the subsurface, mapping the depth and structure of the fissure. Early indications suggest it may extend several miles deep, possibly linking to zones of ductile deformation near the base of the crust. If verified, this would mean the rift is not a superficial crack, but a genuine tectonic feature, a nascent fault system growing in real time beneath one of the continent's most critical watersheds. The red alert remains in effect, serving as both warning and catalyst for unprecedented scientific collaboration. Institutions across the globe have offered to contribute data, modeling expertise, and satellite resources to monitor the unfolding phenomenon. What began as a localized anomaly has become an international focus of research, uniting geologists, climatologists, and engineers in a common pursuit, understanding the forces shaping the ground beneath humanity's most vital river. The discovery underscores an uncomfortable truth that even in an age of satellites and technology, the planet retains the power to surprise, to remind civilization of its place within a much older order. Each passing day yields new information, yet the sense of urgency remains. The rift beneath the Colorado River is not merely a geological curiosity, it is a revelation, exposing the living dynamics of a planet that is far from inert. The crust bends, stretches, and fractures in rhythms beyond human comprehension. And now those rhythms are touching the lifeline of the American West. As the satellites continue their silent watch, transmitting data that may redefine the region's future, one fact stands unshakable. The earth beneath the Colorado River is moving, and with it, the fate of everything built upon its banks trembles in the balance. If you like this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us? What are your thoughts on the red alert beneath Colorado River? We want to hear from you. Thank you for watching, and see you next time.